Okay. So, for those that weren't here, just a bit of a recap. I'm just going to run through the answers to the first few questions that we talked about. Okay, so remember we're talking about, in this PowerPoint and the next one, we were talking about the idea of epidemics and I guess what influences the spread of disease. So that's really what we're talking about in this first sort of half of the epidemic side is what are the things that cause spread? What are some of the factors? So we said, 3 factors that could increase the chances of epidemics. There's a whole range, but we talked about some things like what happens if we have some sort of mutation to the pathogen. So if the pathogen mutates, becomes more virulent, which is the ability to sort of cause disease, that can increase the chances of an epidemic. We could have the shift from an animal virus or an animal strain to a human. So if that mutates and becomes be able to infect humans, that can have a big impact. Because you think about the majority of the main epidemics and pandemics we've seen have been from viruses or pathogens that have started in animals and then transferred to humans, right? We also said possibly, if we do get possibly international travel or travel where a new group is infected that we previously just didn't expect, right? That could lead to increased chances of an epidemic. We looked at this table where we're just trying to slot in, potential diseases or potential pathogens that would be influenced by these factors or the other way around. So we said, well, what sort of diseases tend to be seen in places where we have poor sanitation? That'll be things like cholera. Generally, sort of bacterial infections we tend to see in poor sanitation areas. Because the water or sources or whatever get contaminated by bacteria, people drink them, and that becomes an issue and people get infected. Yeah. In terms of HIV, remember HIV is the pathogen, that's the virus. The disease caused by HIV is AIDS. All right. And the factors that would influence the spread of AIDS, a range. The majority of the factors all boil down to poor knowledge and poor education around the spread of AIDS. Okay. And then that can lead to, mismanagement of sharing of needles or talked about non-use of protective sex and things like this. All right, but again, most of the things around AIDS tends to boil down to the knowledge and the background knowledge. In terms of poor herd immunity, really any disease that most diseases tend to be influenced by poor herd immunity in some form. Remember, herd immunity just means that for whatever reason, the majority of the population is immune. Okay, now that could be natural immunity, could be through a vaccine, whatever it is. If we have poor herd immunity, it just means the majority of an area is not immune. So even like the common cold could be a disease that's influenced by poor herd immunity, or potentially things like measles, where people now are not getting vaccinated for whatever reason, and so that can lead to the spread of that particular disease. Malaria, we said, is a parasite or a plasmodium sort of pathogen. That can be influenced by the presence of mosquitoes or stagnant water sources and things. Okay, so there's a range of different types of diseases that are spread through different ways. We then talked about this third question, which looks at the HIV/AIDS epidemic, which sort of started in the 80s, but even then, as early as 2007 to 2014, which is where these numbers come from, we're still getting a large number of HIV infections. So the top row shows us the number of HIV infections. Remember, that's the pathogen. So this many people have been infected by the pathogen. We can see that the numbers are steadily rising. They're going up. Whereas the death from AIDS, which is the disease, seems to be going down. All right. And we created Kane. Come on in. It's been a long, long time. Join in. We're just talking through some questions. I'm going to come over chat to you in a second, but for the moment, jump on. All right. So we talked about we created a graph of what that looks like. Now, I think I've got the graph here somewhere. Where was it? Did I have it here somewhere? We looked at the graph and we said it looks something like this when it comes up. And we can see this blue line shows HIV infections, the orange line shows the death from AIDS. What are some conclusions we can draw from that? And we said, well, first of all, we noticed that, while the infections are going up, deaths are decreasing. So that could potentially mean that our treatments are better, our knowledge is better about the disease. Okay, so more people are getting infected, but less people are dying, which is a good thing. And that might come down to, treatments and knowledge. We said the second thing is, I don't know, potentially, or one of, my thought is, we're seeing an increase in infection. That sort of goes against what we think should be happening. If knowledge is increasing, shouldn't infections be going down also? Yes. We said, look, that could be due to a couple of things. Maybe it's due to the fact that, we just have better testing procedures now. So we're testing more people. Okay. No, take your phone out. Take out your charger. Sorry? You can't plug a charger in unless it's been tested by the school. It doesn't have a tag on it. So unless it's been tagged and tested by us, we can't have them plugged in. I'm sorry to say this, sir, but I think that is crazy. It's not my rule, mate. It's a school rule. They're not me. We've been told by the school that you're not meant to have your own chargers unless they've been tagged and tested. Because we can't guarantee they won't have issues. Well, that's my rule. Deal with it or not. Bring your phone charged. I am? Yeah, sure am. So yeah, we may just have better testing procedures, which would lead to an increase in the number of confirmed cases. Because remember, this is just the confirmed cases that we're seeing. Guarantee you it's not every case potentially, right? And it's the same with like the COVID-19 thing now. We're saying that there's no cases in SA over the last 12 days or 4 to 13 days or whatever it is now. Whether that's 100% accurate, who knows? There might be some people that are asymptomatic that may have the disease, but we're just showing the confirmed cases. So that might be due to better testing and quicker and cheaper testing potentially. And I think it's close to pretty much where we got to. So that was some of these things. We talked a little bit about some factors that might make curing AIDS difficult. Anyone want to give me their thoughts on that again? We were talking about it. So why is AIDS something that's been around for 40 years now, roughly? Why haven't we cured it? If it's something that's killed so many people, it's a virus. Why can't we create a vaccine, and why aren't we curing AIDS, or why haven't we? We've got this big COVID thing now, and you've got 1 million people working on it at the moment. Franco, what's your thoughts? Yep. Yeah, the fact that it tends to, people can have the HIV virus for 10 years before you get the AIDS disease. You can incubate a long time and it sits dormant within cells. And being a virus, it can be, it goes into the cell, so it's hard to find essentially in the body. And it can sort of re-emerge. Yeah, it's similar to like the cold sore virus. If anyone's AIDS cold sores, same idea. We can't really create defenses because you get a cold sore, but then it goes dormant within cells that all of our, I guess, treatments can't really reach. They go into the cells, or we can't reach the actual virus itself, and so it shows up later on. Similar to the AIDS thing, it sort of hides itself within the body, stays dormant for a long time. Any other ideas why AIDS might be difficult to cure? its form, yeah. So what it looks like, it tends to mutate weirdly. Yeah, so it's the way that it interacts with our body. Yeah, it can mutate sort of within, and it changes its form even within our body, which makes it hard. It could spread very quickly, potentially. So initially, when it was coming out in like the 80s, it spread really, really quickly. Now that we know more about it, it can, we're better at handling it. Yeah. All right. Now, don't think we got to part D. I think we stopped on C. So, what are some factors that might help slowing the epidemic? Do you think? Say back in, whether it's now, whether it was back in sort of the 90s when we sort of made big changes. What are some things that we could do to help slow the AIDS or the HIV epidemic? Do you think? Or what did they do at the time? Do you reckon to try and slow it down? Because it was pretty deadly back in sort of the 80s. We got a bit of a handle on it. It's still killing a lot of people, but we have slowed it. So, what do you think they might have done at the time? Any ideas?
Government give the awareness of the surveyors. They give the health education.
Yep.
For the people.
Yep.
To make them aware about this.
Yeah, totally. Yeah.
And it's a symptom and the transmission.
Yep.
Of diseases.
Yep.
So that it is slowing down of death rate.
Yep.
So it is increase the infected race.
Yeah. Yep.
And another one. And the government gives the health education for health education gives the okay sorry
It's all right.
If the patient is secure in the primary stage,
Yep.
And he or she take the medicine for the long period of time, the disease eradicate from their bodies.
Yeah, really good. Yeah, it's a good point. So, your 2 points were obviously increased education. Is it probably the biggest factor, really? Because at the time they didn't fully understand how it spread. They didn't know, a lot of people were a bit unsure. And you're right, education was probably the biggest first step to know how it's transmitted. And now, the majority of people that have HIV or AIDS, realistically, as long as you're careful, it's relatively uncommon to catch it from someone, because we know that really it's just transferred through blood or semen, essentially. That's the only two ways you're going to get it. So as long as you don't, practice safe sex and don't share needles and be careful if someone's cut themselves, you're pretty safe. So, right, education, and you're right, medication was the second biggest one. So recently, you're right, now we have antiviral drugs that essentially can cure AIDS. It's not a vaccine, but if you catch it early enough, you're right, like in that first stage, you can get it to a point where clinically they are actually cured. Now, doesn't mean that the virus is 100% gone from their body, but it just means that we don't have tests that can test for it. Well, we have tests, but they won't show up on the test, and you can't transmit it from one person to another. So essentially, as long as you can't transmit a virus, you're essentially cured. That's what they say. So, yeah. So there, to me, that would be the two biggest factors in terms of slowing down the epidemic. Anyone have anything else they want to add or share, or any thoughts? We're going to talk about sort of control of disease today. After this, we'll go through disease control and different things that we do to slow down epidemics and how we control these things. So we'll get to that in a second. All right, antibiotic resistance. What does it mean? Anyone want to give us their thoughts? What do we mean by antibiotic resistance? Explain it then. What's your thoughts? So yeah, I agree. The words are there. What do they words mean? To antibiotics, yeah. How does that come about? Why? How? So initially, very few bacteria were resistant to antibiotics. So how has antibiotic resistance come about? Why is it worse now than what it was? Yeah. Good.
Like kind of like, I mean, I don't know if it's the same thing, but you know how you get a new flu shot every year?
Yep.
Because it changes. There you go.
Yeah, same idea. Yeah, the same. It's
Same preference, really.
yeah, it's the same
concept.
Yeah, same concept. I agree. So it's the fact that bacteria are potentially mutating. Yeah, I agree with that. Any other ideas why? So mutation is part of it. Why? What else is leading to antibiotic resistance, Franco? Yep. Yeah. Yeah, yeah, totally. It's all about competition, right? It's sort of like, and that's essentially what natural selection is in a way, right? It's like saying, in this room, if we had one apple for all of us to share as food, and the doors were locked, we can't get out. We have one apple there, right? Okay. And, say the chances of me getting that apple is pretty low against everyone else. Yeah. I'm like a 1 in 8 chance of getting that apple. Yeah. But if I'm immune to some sort of toxin, and all of a sudden all you guys die off, sweet, I've got access to the apple, right? And I can go eat and I can survive, whereas you guys don't. Same idea with antibiotic resistance. There are very few bacteria that are resistant initially. Through mutations, they might become resistant. And you're right, even if there's 1 out of 1,000, if the 999 get killed off by the antibiotics, then that one will have a greater chance to survive and to create more antibiotic resistant bacteria. And if this happens often enough, then we start getting more of the antibiotic resistant bacteria, and that becomes a bigger issue. To antibiotic resistant bacteria? Not serious. It's not about fighting. They won't fight each other. It's more about competition for resources. So yeah, they would just grow until they hit a point, and then they probably wouldn't grow anymore. They don't really kill it. They're not going to kill each other necessarily. No, not really. They don't really infect other bacteria because bacteria are generally sort of like unicellular. They're only one cell, so there's no real advantage to infecting another bacteria. Nah. Generally, like if you had a plate, like an agar plate, and you put one bacteria on each, they would just grow out from that point until they hit the point in the middle, and they just wouldn't grow anymore. They wouldn't take over generally. If one grows quicker, it might take up a larger portion, but they're not going to kill each other off. Oh, totally. Yeah, yeah. So yeah, that's essentially how a lot of these bad viruses are. So they'll be like an animal virus, and they'll be like a human virus, and for whatever reason they combine and they create a new hybrid virus. So it's what we talked about a couple of weeks ago, or end of last term. It's called antigenic shift, where you get two viruses coming together and making like a mutated or hybrid virus. And they tend to be the worst. So things like the H1 flu virus and oh no, not that one. Would it be like SARS? Even probably be an example. So majority of like the worst viruses we see tend to be mutated animal viruses that have come about, and like swine flu, bird flu. They're all essentially they've come from an animal. They mutate. They might hybridize with one of our viruses, become like deadly, and they're not good because our body doesn't tend to have natural resistance against these things, which is not very good. Totally, yeah, no, you can't blame the body. It's doing the best it can. Everything's happening a lot quicker than what it used to. Yeah, totally. So why are there now fears this could be a greater risk than AIDS? So why is antibiotic resistance possibly worse than, say, the AIDS virus? We know we're killing a lot. What's the big risk with antibiotic resistance? Why has it become such a bad thing? Yeah, I like that idea. Yeah, so we have medications against AIDS, whereas antibiotic resistance essentially is we don't have any resistance. That's the point. So they can be very deadly. You're right. Yeah, 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 totally. Yep, I agree with that. So yeah, the fact that if we do have an antibiotic resistant bacteria, you're right. Not many companies, if any, are creating new antibiotics just because it's costly, it's timely, takes it's not an easy thing to do. And you're right, it takes too long, and by the time we have created antibiotics against it, it's done a lot of damage. True, yeah, that's part of it as well, and that's what we're seeing now. Like that's the risk of something like COVID is it takes so long to create vaccines. People think, oh, we get a virus, we just create a vaccine in seconds. Well, no, it's going to take, yeah, it's going to take upwards of 12, 18 months to create a vaccine that's viable and has been tested. So it takes a long time for these things to happen. Takes months, like 6 months. Yep. Yeah. So I'll test it on probably mice. Yeah. Generally, they'll inject it, see if they gain antibodies from against the virus. Does it, what adverse effects? It can take months and months, and that's the problem. You have to, if you put it into a human, you still have to look at them over a number of months to see if there are any, downsides. Is it going to kill people? It's a risky thing because if you fast track it and you put this vaccine out, you think about 60-70% of the population will have that vaccine. If it's deadly, then we're screwed. So they're not going to rush it, I wouldn't think.
I mean, that's kind of smart. I was the question on that. I wouldn't rush it.
No, totally. That's right. Yeah, you're better off containing it for now. Spend the time, get a vaccine that works, use that appropriately. So, why does herd immunity? First off, does someone want to tell me what herd immunity is, and why does it only apply to contagious diseases? Sort of a two-part question. So we talked about herd immunity just before. Anyone want to tell me what it is? Yeah, totally. Yeah, that's the idea. Again, we use this class as an example. There are 3, 6, 7 of us. Even if 5 of us were immune and 2 of us were not, if me and Kane were not immune, the chances of it spreading to Kane are very low because I can't spread it to Ohm can't spread it to Franco, and so we cut off that chain in order to get it to Kane, right? Yeah, but because and again, it's luck of the draw. Even if it was just me and Ohm, the ones that were not vaccinated, I can infect Ohm, but it's not going to travel further than this room because everyone else is immune. So the more people we can have immune, the greater the stop of the spread is going to be. And you can see why that only applies to contagious diseases because the contagious diseases are the ones that spread. So, if you had a disease that couldn't spread, it's not going to matter if your people are immune or there is no immunity to something that's not going to spread because it doesn't matter. You're not going to catch it off me. So, cancer, for example.
I guess you could say severe one, but that also travels extremely.
Like a virus that travels quickly. The most virulent strain. It's a good question. I think. What was I was looking at some numbers. I think SARS was one of the most most virulent in terms of spread. Even just the influenza virus is pretty. It's not the most deadly, but in terms of spread, it's one of the worst. Spread pretty quickly. Common cold spreads pretty quickly. Yeah, there's a lot of viruses that spread pretty easily. But yeah, So so diseases like cancer and stuff obviously aren't contagious, so there is no such thing as herd immunity, from that. There is this particular bacterium called Staphylococcus aureus or golden staph. You might have heard of it. It's relatively harmful for most people. However, it's become a bit of an issue, particularly in hospitals lately. So, what are some people that might be vulnerable to golden staph? So, we know that most people are relatively harmless. What sort of groups of people do you think it might be harmful for? Just a bacteria. So any bacteria in general, what sort of groups tend to be the most vulnerable to bacterial infections? Yeah. Yep. Yeah, totally. Why? Why would elderly and younger people tend to be the most vulnerable? What sort of influences? Yeah. Yep. Totally. So pretty much people that are immunocompromised. So you're right. Old people, their immune system isn't as good as it used to be. Younger people they haven't developed an immune system that's strong enough yet. People that have diseases that might lower their immunity potentially might be, at risk of getting infected by these particular bacteria as well. Yep. Why do you think it kills so many people in hospitals, though? It's one of these weird bacteria. In the general population, it's fairly harmless. In hospitals, it tends to be quite deadly. Yeah, totally. Yeah. Yep. Mhm. Yeah. So it's a good point. So the fact that we just said that, people that tend to be immunocompromised or elderly or frail already are at risk. So generally in hospitals, you see a lot of sick people, so they can potentially be infected. Yeah. Mm. Yeah, I agree with that. Any other ideas why hospitals might be somewhere where we may have issues? Yeah, potentially. So in terms of golden staph itself, I mean, yeah, they're not into like guessing. We're just talking in terms of like bacteria. Why would bacteria kill more people, or these relatively harmless bacteria kill more people? Again, it comes back sort of to antibiotic resistance a little bit. So hospitals, unfortunately, are because they're one of the most sterile and antibiotics are used the most in hospitals. There tends to be a lot of antibiotic resistance that develops in hospitals because that's where we use a lot of these antibiotics in a hospital setting, so they can develop a lot of antibiotic resistant bacteria, in particular antibiotic resistant golden staph, and all of a sudden that starts killing people off because the antibiotics don't tend to work, and they can cause disease there. Why? There are some cases, like we have had cases of small spreads. Now it's interesting. This was actually, at the moment, yeah, look, it's bad, but it's not as bad as it could have been. We have had some cases of, large spreads of disease over the last sort of 10, 15, 20 years. Why is it unlikely that we're going to see something like, the bubonic plague that killed off, a third of Europe? Why would we probably not see something like that today? Yep. 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 Huh. Continue. Yeah. Yep. Yep. Yeah, I totally agree. And again, at the end of the day, education is probably one of the biggest predictors of spread of disease. You're right. If we know now the majority of how bacterial spread of our viral spread works. That makes a massive difference. Back in the 1300s, they sort of understood the idea that quarantine was important, but they didn't really understand how close you could get and what you could do, so it spread quite easily, especially initially. And you're right, I think this particular virus has been sort of mismanaged, especially at the start, and you could see why that, if you see in some countries why it's so bad compared to others, comes down to management of the disease generally. Like, there's other factors as well, but there are some countries that have just been hit so much worse because they have mismanaged it. And you're right, initially, if they stopped the spread, stopped travel, we probably could have stopped it a lot quicker or sooner. Didn't happen. Yeah. So yeah, I agree. And it comes in, plus, medicines and stuff now are better than they have been. Better equipment, better, personal protective equipment, things like that makes a big difference as well. The extension-y part, look, I'm not going to go through it too much. It was just about looking at, any disease and why it would have developed into an epidemic and where it is at the moment. If anyone's done it and they want to tell us about a disease, feel free. I'm guessing maybe. Has anyone done the extension? Not yet. Just hold on for a bit. Don't need it yet. I'm just going to go through the next bit and then you can. So if anyone doesn't have any additional stuff, I'm going to move along. I just wanted to go through those questions though.